Here in this lesson, I am giving you the answer of the questions of 6th mock test held on 14 June. Now, let us consider the first question. It is a pulley problem. Let us see. In the figure, the blocks A, B and C of mass m each have accelerations A1, A2 and A3 respectively. F1, F2 are the external forces of magnitudes twice mg and mg respectively. Then, now here in the first picture, there is a mass m is hanging, so the corresponding weight mg is actually acting in the downward direction. So the net external force acting on the system is 2mg twice mg. For the higher force, the system will go down here. So m mass will go off. So the net force is twice mg minus mg. Hence the acceleration is only m is the mass of the system. So 2mg minus mg by m, that is your g. So the acceleration of the system in this case is g. For the second diagram, there are two masses hanging. For the mass twice m, corresponding weight twice mg is acting in the downward direction, and for mass m, mg is acting in the downward direction. So acceleration A2 is in the downward direction, that is the direction in which twice m mass is descending. So the net force is twice mg minus mg, because the motion is in the downward direction of twice m mass, so m mass will go up. So twice mg force is acting in the downward direction. Mg is actually acting here against the direction of motion. That is why resultant force is twice mg minus mg divided by total mass, whole mass of the system, that is your m plus twice m, that is thrice m, that is equals to g by 3. For the third diagram, here is a force mg and another mass m, corresponding weight is mg in the downward direction, and mg weight is also in the downward direction, but twice mg is greater than mg. So m mass to the right side, m mass will go in the downward direction. Hence net force acting is twice mg minus mg, because mass weight of c is acting against the direction of motion. Here the acceleration is a3 of the mass capital small m, and where mg external force is also acting, it is in the downward direction acceleration. So net force is twice mg minus mg by total mass of the system. Here is a mass m and here is another mass m, that is total mass is twice m. So the acceleration is g by 2. So considering the whole problem as a whole, A1 is greater than any A2 or A3. So A1 is g, A2 is g by 3 and A3 is g by 2. So A1 is maximum, then A3, then A2. So B is the correct option. So correct choice of the question number 1 is B. Now let us consider the second question. In the second question, we see that two masses, 10 kg and 20 kg respectively, are tied together by a massless spring. A force of 200 Newton is applied on a 20 kg mass, as shown in figure. At the instant shown, the acceleration of the mass 10 kg is 12 meter per second square. 10 kg mass having acceleration 12 meter per second square, so the force acting on it is F equals to ma, that is your 12 into 20, that is 20 kg mass. A force of 200 Newton is applied on 20 kg mass. At the instant, the acceleration of 10 kg mass is 12 meter per second square. So the force acting on the 10 kg mass is 120 Newton, that is 10 times 12, that is 120 Newton. Hence, the reaction force on the 20 kg mass is 120 Newton in the backward direction. Hence, the net force on 20 kg mass, 200 Newton towards right and 120 Newton towards left, Hence the net force is 200 minus 120, and the acceleration divided by total mass of the body, that is your 80 by 20, that is 4 meter per second square. Hence our correct option is C. So the correct choice of the question number 2 is C. Now let us take the third question, question number 3. Question number 3. In question number 3, we see that it is a problem from friction. 40 kg slab raised on a frictionless floor. Here is the 40 kg slab, it is resting on a frictionless floor. A 10 kg block rests on the top of the slab. A 10 kg block is resting on the slab. The coefficient of friction between the block and the slab is 0.6, while coefficient of kinetic friction between the block and the slab is 0.4. So static friction mu s is 0.6 and mu k kinetic friction is 0.4 here in between the block and the slab. The 10 kg block is acted upon by a horizontal force 100 Newton. G equals to 9.8 meter per second square, the resulting acceleration of the slab. So we are to calculate the resulting acceleration of the slab, that is the 40 kg mass. Now let us consider the acceleration of the whole system. So the acceleration of the system equals to net external force, that is your 100 Newton, divided by total mass of the system 10 plus 40 kg, that is your 50 kg. So the acceleration of the system is 2 meter per second square. Now, why the 40 kg mass is moving? It is only due to the frictional force. So let us see the maximum acceleration of the acceleration for the mass 40 kg. Now the frictional force is mu mg. So the when we are actually calculating the maximum force, mu is mu s, that is 0.6. m, gm is actually 10 kg. For the mass 10 kg, the reaction force is acting. So 10 into g, 9.8, whole divided by the mass, that is your 40 kg. So this is 4. So it may be 1.47, that is your 4.9 by 2, and this is 0.3. So this is 1.47 meter per second square. So the maximum acceleration when the block system will move together is possible 1.47 meter per second square. But the acceleration due to the applied force of the whole system is 2 meter per second square. So the system will not move together. So there is relative motion. So we have to consider the kinetic friction in this case for the motion of the mass 40 kg. So when kinetic friction is acting, frictional force is mu k into mg, that is your mu k is 0.4, m is 10 into g. So the acceleration A in this case is 0.4 into 10, g is 9.8 divided by 40. So this is 4, this is 10, so this is 0.98. So the acceleration is 0.98 meter per second square. So our correct choice to the question number 3 is A. Now let us take the question number 4. In the question number 4, a body takes time t to reach the bottom of an inclined plane of angle theta with the horizontal. If the plane is made rough, time taken now is twice t. The coefficient of friction of the rough surface is, here is the inclined plane, it is the inclined plane problem, and when the inclined plane is smooth one, the mass will take smaller time. But if it is rough one, due to the presence of the frictional force, the mass will take larger time, and here the time is twice than the previous one. So if the length of the incline is L, so when there is no friction, L equals to half acceleration g sine theta into t square. But when the frictional force is acting, then L equals to half. Actually the acceleration is now g sine theta minus mu g cos theta, and time taken is, in according to the problem, is twice t, that is twice t whole square. So equating L we get this is equals to half g sine theta into t square. So half maybe cancel out and g also cancel out. and we get, dividing left hand side by sin theta, 1 minus mu cot theta equals to, also t square will be cancelled out here. So it is 2 into 2, 4. So this is equals to 1/4. So mu cot theta equals to 1 minus 1/4, that is 3/4. And here we are to calculate mu. So mu equals to 3/4 divided by cot theta, that is 3/4 into tan theta. In this case, we may also apply a short tricks. Mu equals to 1 minus 1 by n square into tan theta, where n is 2 here. So mu equals to 1 minus 1/4 into tan theta, that is 3/4 tan theta. So 3/4 tan theta is the correct choice. So the correct choice to the question number 4 is A. So the answer of the question number 4 is A. Now let us take the fifth question. What does it say actually? Fifth question. In question number 5, we see that a tube 1 meter long is filled with liquid of mass 1 kg. The tube is closed at both the ends and is revolved about one end in a horizontal plane at 2 revolutions per second. The force experienced by the liquid at the other end is. Now, here is a tube which is actually the tube is closed at both ends and it is rotating. It is rotating in the horizontal plane with 2 revolutions per second. That is, the angular velocity is 2 into 2 pi, that is your 4 pi radian per second. Now, whole mass of the liquid is not revolving in the same circular track. Here, the mass distribution is symmetric about the center, so we will take it as a center of mass problem. It may be taken as the total mass is concentrated at the center of the tube, and the radius of the path is, let it be r. Then the force acting F equals to m omega square. If the length of the tube is L, m omega square, L by 2. It is taken that the whole mass is concentrated at the center, so the force is acting on the other part due to the centrifugal force, and which is m omega square r. Here r equals to L by 2, that is the distance of the center of mass from the axis of rotation, that is your OC. Here m, the force experienced by the liquid at the other end, mass is 1 kg. So m is 1 kg, omega is 4 pi whole square, and L, tube is closed, 1 meter long tube. Here the tube is 1 meter long. 1 meter long. So L by 2, m omega square r. So m omega square into L by 2, m omega square into r by 2. So r is actually L by 2. So this is L is 1. Here r is half into half, 1/4. So our correct option is m omega square L by 2, m into omega square 4 pi whole square, and L by 2 is half, so it is 8 pi square. So B is the correct answer. So the correct answer to the question number 5 is B. Now let us take the question number 6. A boy of mass 40 kg stands in a frame of mass 360 kg. He pulls on a light rope which passes over a pulley. The other end of the rope is firmly attached to the frame. What force should be exerted by the boy on the rope for the system to be in equilibrium? Here is a pulley, and the pulley is smooth one. Let the tension at one side is a T, so the tension to the other side is also T. So the total upward tensional force is twice T. And the mass of the frame is 360 kg, and the other end of the rope is firmly attached to the frame what force should be exerted by the boy on the rope of the system, and the mass of the boy is 40 kg. So total downward force is acting is 360 kg plus 40 kg. So 400 kg weight, 400 g is acting in the downward direction. So net external force twice T equals to 400 into g. So here T is 200 g. So our correct option is C. So the correct answer to the question number 6 is C. Question number 6 is C. Now let us take the question number 7. In question number 7, we see that a particle of mass m at rest is acted upon by a force P for time t. The kinetic energy after an interval of small t. A particle of mass m at rest is acted upon by a force P for a time t. Hence the impulse of the force, that is your P into t, equals to change in momentum, that is your mv, where m is the mass of the body and let the momentum of the body be v. We want to know the kinetic energy, that is your small p. Kinetic energy E equals to, we know that p square by 2m, and p equals to capital P into t. So this is capital PT whole square by 2m, that is your p square t square by 2m. So B is the correct choice. So the correct answer to the question number 7 is B. Now we switch over to the question number 8. In question number 8, we see that power supplied to a particle of mass 2 kg varies with time as P equals to 3t square by 2 watt, where t is in second. If the velocity of the particle at t equals to 0 is v equals to 0, the velocity of the particle at time t equals to 2 seconds will be. We have to calculate the velocity in that time. Here p equals to 3t square by 2. So the power is a function of time. Here is a variable power is acting. So in order to find the velocity, we have to take the application of calculus. P equals to 3t square by 2. So P equals to F into V equals to 3t square by 2. F means m dvdt. M dvdt into V equals to 3t square by 2. So separation of variables yields us m is the 2 kg mass, m is 2 kg into V dV equals to 3t square by 2 into dt. And we have to integrate to find the relation between velocity and time. So it is given that boundary condition actually gives given us t equals to 0, v equals to 0. So when t equals to 0, we may put v equals to 0 as the lower limit. And we have to find the velocity of the particle at t equals to 2 seconds. So t will vary 0 to 2, and we have to find the velocity, let it be v. Let it be small v. So integrating, we get 2v dv equals to v square. 2 into v square by 2, that is v square. And putting the limit 0 to v, that gives you v square by 2 equals to 3 into t square dt, 3 by 2 into d square t square dt, whose integration gives t cube by 3, and limit goes from 0 to 2. So this is equals to 2 cube by 2, that is your 4. V square by 2 equals to 4. V square, this is your v square by 2, not 2 into v square by 2 actually. 2 will cancel out, v square equals to 4, so v equals to 2. So the correct answer to the question number 8 is A. Now let us take the question number 9. Question number 9, it is a question from geometrical optics, ray optics. When an object is kept at a distance of 30 centimeter from a concave mirror, the image is formed at a distance of 10 centimeter. If the object is moved with a speed 9 meter per second, the speed of the image moves. So here in this problem, speed of the object is given, we have to calculate the speed of the image. So what we need the velocity expression. We know that the distance expression 1 by v plus 1 by u equals to 1 by a. This is the general equation for spherical mirror. Now differentiating both sides, with respect to t we get minus 1 by v square dv dt minus 1 by u square du dt equals to 0, because the focal length of a mirror is constant, so its first order differentiation will yield 0 only. So dv dt equals to minus v by u whole square into du dt. So minus, what is the value of v? Image is formed at a distance 10 semi, object distance is 30 semi. So v is 10 semi, u is 30 semi. So v by u is 10 by 30 whole square. And what is du dt is 9 meter per second. So this is 9. So minus 1 by 9 into 9. So minus 1 meter per second. So the speed of the image is 1 meter per second. So our correct choice for the question number 9 is B. Now let us take the question number 10. It is also a concave mirror problem. A object placed in front of a concave mirror at a distance x centimeter from the pole gives 3 times magnified real image. We know that u equals to f plus f by m. When we get 3 times magnified image, so m is 3, so u equals to 4f by 3. If it is moved to a distance x plus 5, the magnification of the image becomes 2. When the magnification becomes 2, then u equals to f plus f by 2. So u2 equals to 3f by 2. In the first case, the distance was x, now it is x plus 5. So u2 minus u1 is actually 5, because the image object distance changes from x to x plus 5. It has been enhanced by 5 centimeter only. So if we get the difference 3f by 2 minus 4f by 3, that will give us 5, or HCF 6 9f minus 8f equals to 5. So f equals to 30 centimeter. So D is the correct option. Correct option to the question number 10 is D. Now see the next question. That is our question number 11. This is a question from geometrical optics. When a ray enters a refracting medium, it is found that the magnitude of angle of refraction equals to half the angle of reflection. Refracting angle is half the angle of reflection, and angle of reflection equals to angle of incidence. If mu is the refractive index of the medium, then the angle of incidence is. Now let us draw the ray diagram. Let the angle of incidence is I, then the angle of reflection is I, and angle of refraction according to the problem is R. Now let us take the refractive index of the medium as mu, and the first medium as 1, it is taken as air. Then applying R equals to I by 2 according to the problem. So applying Snell's law for the refraction at the point B, we get 1 into sin I equals to mu into sin I by 2. But we know that sin I equals to twice sin I by 2 into cos I by 2 equals to mu sin I by 2. So our sin I by 2 will be cancelled out from both the sides. So cos I by 2 equals to mu by 2. So I equals to 2 cos inverse mu by 2. So I equals to 2 cos inverse mu by 2. So our correct option is B. So the correct answer of the question number 11 is B. Now let us take the question number 12. A bulb is placed at a depth 2√7 meter in water, and a floating opaque disc is placed over the bulb so that the bulb is not visible from the surface. What is the minimum diameter of the disc? So we have to calculate the minimum diameter of the disc. Here the disc is floating, the bulb is just under it, and one cannot see the bulb from the upper surface. So this is the picture. Rays of light are falling at the critical angle and the angle of refraction is 90 degrees. So the object, that is your bulb, is not visible from the top. So in this case we know that if it is R and the depth is H, we know that the relation between R and H is R equals to H by root over mu square minus 1. Here H is 2 root 7 and mu for water is 4 by 3, all you know. This is 4 by 3 whole square minus 1. So this is 2 root 7 by root 16 by 9 minus 1 equals to 2 root 7 by root 7 by 3. 3 into 2 equals to 6. So diameter D equals to twice R equals to 12 centimeter. So correct option is B. So the correct answer for the question number 12 is B. Now take the question number 13. Now let us take the question number 13. In question number 13, it is a question from prism. White light is incident on face AB of a glass prism. The path of the green component is shown in the figure. So white light is incident on a surface and the green light is actually critically refracted. Just critically refracted. So the angle of refraction for the green light is 90 degree here. Total internally reflected at face, just total internally, just it is going through the surface. Now the question is, the light emerging from the face will contain which color will be there in the emerging light. Now, when the angle of incidence to the second surface is theta c, we know that sin theta c equals to 1 by mu. It is taken that the refractive index of the outside medium is 1 and refractive index of the material of the prism is mu. Now, mu equals to c by v. So this is equals to 1 by mu equals to v by c. And v equals to n lambda by c. So theta c is proportional to sin theta c, actually is proportional to lambda. So theta c is larger, theta c larger for larger values of lambda. That is from green VG, we know that VI, BG, Y, OR. So yellow, red and orange having greater critical angle. So they will come out of the surface. So yellow, orange and red colored light will emerge out of the second surface. So the light emerging from the surface will contain yellow, orange and red colors. A is the correct option. So the correct answer to the question number 13 is A. Now let us take the question number 14. What does it say? In the question number 14 we see a telescope has an objective lens of focal length 200 centimeter and an eyepiece of focal length 2 centimeter. If the telescope is used to see a 50-meter tall building at a distance of 2 kilometers, what is the height of the image of the building formed by the objective lens? So you have to consider the actually action of the objective lens only. We are here interested to see a building of height 50 meter and which is at a distance 2 kilometer, that is your 2000 meter. And the focal length of the lens is f0 equals to 200 centimeter. Now just in this manner the ray will go through the optical center and the object is far away, so the image will be formed at the focal plane of the objective lens, in fact. Hence, considering the similar triangles, we may write down that the height of the image of the building be D. Then we may write down that this is 200 centimeter. So 50 by 2000 equals to d by 200. D by 200. So d equals to 50 into 200 by 2000. So 10, 5, 50 by 10 equals to 5. So the height of the image is 5 centimeter. So the correct answer to the question number 14 is A. Now let us take the question number 15. Question number 15. Next question is question number 15. It is also a question from prism. A prism of certain angle deviates the red and blue rays by 8 degree and 12 degree. Another prism of same angle deviates the red and blue color by 10 degree and 14 degree respectively. The prisms are small angled and made of different materials. The dispersive power of the material of the prism. We know that dispersive power P equals to delta V minus delta R by delta. Delta V is the deviation of the violet color, delta R is the deviation of the red color, and delta is the mean deviation. So delta equals to delta V plus delta R by 2. So for the first prism, delta is what? Delta V is 8 degree and delta R is 12 degree. So delta is 8 plus 12 by 2, that is your 10. So here delta V, blue rays are deviates red. Red is 8 degree and blue is 12 degree. So delta V 12 minus delta R 8 and delta is 10 degree. So we get P1 dispersive power of the first prism. Similarly, dispersive power of the second prism. Here delta red 10, delta violet 14, 14, then 14 degree minus 10 degree by delta is average of the two, that is your 12 degree. So it is 4 by 10 for the first case and this is 4 by 12 for the second case. Then the ratio P1 by P2 equals to 4 by 10 divided by 4 by 12, that is your 12 by 10, that is your 6:5. So the correct answer is C. So the correct answer to the question number 15 is C. Now let us consider the question number 16. A convex lens A of focal length 20 centimeter and a concave lens B of focal length 5 centimeter are kept along the axis with a distance d between them. If a parallel beam of light falling on A leaves B as a parallel beam, then the distance d in centimeter. We have a convex lens of focal length 20 centimeter and a parallel beam of light is incident on it. So this parallel beam of light should meet at the second focal point, and that is the distance of the image from the lens is 20 centimeter. Now there is a concave lens of focal length 5 centimeter and parallel rays are falling on A and leaves B as a parallel beam. So the ultimate beam is parallel. So if these rays from the convex lens incident on the concave lens as a converging rays, then it will diverge them and made them parallel. So when the point of convergence is at the focal plane of the concave lens, then and only then the ultimate refractive rays will be parallel also. So this is the focal distance OF2 is the focal distance of the concave lens FC. This is 5 centimeter and in the first case image distance was 20 centimeter and so the distance in between the two lenses is 20 centimeter minus 5 centimeter, that is your 15 centimeter. So the correct choice is B. So the correct choice to the question number 16 is B. Now let us take the question number 17. In question number 17, we see that the temperature of the gas contained in a closed vessel increases by 1 degree centigrade when pressure of the gas is increased by 1%, the initial temperature of the gas. So change in pressure and change in temperature is our point of consideration. So we must take that the volume remains constant. Then from gaseous law we know that P by T, pressure by absolute temperature of the gas. This ratio is constant, let it be C. Now, we are interested about the change, and when we are considering the change, there is a procedure. We have to take log of both sides and then differentiate. So ln P minus ln T equals to ln C. So 1 by P dP, differentiating we get, minus dt by T equals to 0. So dP by P equals to dt by T. dP by P equals to dt by T. Now, the initial temperature of the gas is required. So, we have to calculate only T. So, T equals to dP by P, T equals to dt divided by dP by P. dt is 1 degree centigrade, and change in temperature 1 degree centigrade is equals to 1 Kelvin. So, it is in SI system 1 Kelvin. dP by P is 1%, that is 1 by 100. So, the ratio is 100, capital T is 100. So, capital T equals to 100 Kelvin. So, our correct answer is A. So, the correct choice to the question number 17 is A. Let us take the question number 18. For a gas, R by Cv is 0.67. This gas is made of molecules which are either monatomic, polyatomic or diatomic, or mixture of diatomic and polyatomic gas. We have to consider it as gamma, consider it from the value of gamma. We know that R equals to Cp minus Cv, whole divided by here Cv equals to 0.67. So, Cp by Cp gamma minus 1 equals to 0.67. So, gamma equals to 1 plus 0.67, 1.67, and it is for monoatomic gas. So, our correct choice is A. So, the correct choice to the question number 18 is A. Now, let us take the question number 19. In question number 19, two containers of equal volume contain the same gas at pressure P1 and P2 and absolute temperature T1 and T2 respectively. On joining the vessels, the gas reaches a common pressure P and common temperature T, the ratio P by T. We have to calculate the ratio P by T. First of all, the pressure is P1, let the volume be V, then we may write down P1 into V equals to N1 into R into T1, where T1 is the temperature of the gas. In the second case, P2V equals to N2 into R into T2. Now, equal volume, they have the equal volume is V each. Then, on joining the vessel, the gas molecules have a common pressure P and common temperature T, calculate P by T. Now, when they are connected, the number of moles will remain the same. So, now number of moles N equals to N1 plus N2. This should be our equation of consideration. Now, the pressure P, volume is twice V when they are connected. Total volume of the gas is equals to N1 plus N2, that is your N, into RT. We have to calculate P by T, then P by T equals to N1 plus N2 into R by twice V. So, what is N1? N1 equals to P1V by RT1, P1V by RT1. What is N2? Plus P2V by RT2 into R by 2V. R being cancel out and V will also cancel out. Then this is equals to half into P1 by T1 plus P2 by T2, P2 by T2. So our correct answer, correct choice is B. So the correct choice for the question number 19 is B. Now let us take the next question, that is our question number 20. In this question we see that a wire of initial length L and radius R is stretched by length small l, another wire of same material but of initial length twice l and radius twice r is stretched by length twice l, but another wire is of same material having same Young modulus. Mind that. The ratio of stored elastic energy per unit volume. Energy per unit volume, we know that equals to half into stress into strain and if we express stress in terms of Young modulus, then this becomes half into y into strain square. Material for both the cases is same, so y is same, and strain for the first case is small l by capital L, length capital L, change in length small l. In the second case, this is also twice L by 2 into capital L, so strain is also small l by capital L. So strain is same, y is same, so the energy stored per unit volume will be the same. So the correct choice is D, 1:1. The correct choice of the question number 20 is D. Now let us take the question number 21. In question number 21, a metal ball B1 of density 3.2 gram per cc is dropped in water, while another metal ball B2 of density 6 gram per cc is dropped in a liquid of density 1.6. If both the balls have the same diameter and attain the same terminal velocity, the ratio of viscosity of water to that of liquid is. The metal ball B1 of density 3.2 is dropped in water, and another ball is dropped in a liquid of density 1.6. We know that. What is given? Both the balls have same diameter and attain the same terminal velocity. So you have to write down the velocity of terminal velocity expression. Terminal velocity expression Vt equals to 2 by 9 eta, 2r square by 9 eta into rho minus sigma into g. Now for the first case, it is 2r square by 9 eta. Eta, what is eta? Eta, water, into rho minus sigma. Mind that rho of the ball is 3.2 and sigma is 1, that is the density of water, 3.2 minus 1 into g. And terminal velocity for the second one is 2r square by 9 into eta L of the liquid into density of the ball is 6 minus density of the liquid 1.6 into g. So both the balls, metal ball is dropped in water, a metal ball, another ball is dropped in liquid with density. Both the balls have same diameter, so radius is same, so radius may be cancelled out, g is also cancelled out, 2 is also cancelled out, 9 is also cancelled out from the denumerator. So what to calculate us? We have to calculate eta w by eta L equals to 3.2 minus 1, 2.2 by 6 minus 1.6, that is 4.4, that is your half, that is your 0.5. So correct option is B. So the correct option to the question number 21 is B. Now let us consider the next question, that is the question number 22. In question number 22, we see that the rate of flow of a liquid through a capillary tube of radius r is V, when the pressure difference across the two ends of the capillary is P. So V equals to pi P r to the power 4 by 8 eta L, where r is the radius of the tube and L is the length. If the pressure is increased by 3P, now the pressure is P plus 3P, that is your 4P. So pressure is now 4 times and radius is reduced to r by 2. Then the rate of flow becomes, now V1 equals to pi, P is now 4P, R becomes R by 2 whole to the power 4 into 1 by 8 eta L, then the rate of flow. So other factors remaining the same. Now pi P R to the power 4, 8 eta L is taken out. Now here is 4 and in the denominator there is 2 to the power 4 is 16, that is 1/4. So that is 1/4. So the volume is 1/4 now. So the ratio is 4:1. 1/4. So in the first case it was V, now it is V by 4. V1 is V by 4. So the rate of flow is V by 4. So the correct answer to the question number 22 is B. Now let us take the question number 23. In question of 23, an incompressible liquid flows through a horizontal tube as shown in the following figure. Then the velocity V of the liquid is. Now we have to consider the equation of continuity, and it is also taken that it is an incompressible fluid. So from the equation of continuity we know that mass is constant, that is A into V into rho equals to constant. When the liquid is incompressible one, then AB equals to constant. Then the cross-sectional area into velocity of flow equals to constant. So for the inward flow we get it area A into V1 equals to total outlet flow equals to A into V2 is 1.5 plus another outlet flow is 1.5A into V. So we have to calculate then the velocity of V. We have to calculate V here, and V1 is 3 meter per second. So putting V1 3, A into 3 equals to A into 1.5 plus 1.5 AV. So A will be cancelled out from both sides. Now 3 minus 1.5 equals to 1.5 V. So 1.5 V equals to 1.5. So V is 1 meter per second. So V is 1 meter per second. So the correct choice to the question number 23 is C. Now let us take the question number 24. In question number 24, we see that a cylindrical tank is filled. A cylindrical tank is filled with water up to a level 3 meter, and a hole is opened at a height 52.5 meter from bottom. The ratio of area of the hole to the cross-sectional area of the cylinder is 0.1. The square of the speed with which water is coming out from the orifice is square of the speed. Now here is a cylindrical vessel which is 3 meter high, and a hole is opened at a height 52.5 meter from the bottom. Here is a hole which is opened at a height 52.5 centimeter from bottom. So from the top the height is 300 minus 52.7, that is 247.5 centimeter. And the cross-sectional area ratio is given, the square of the speed with which the water will coming out. Now we may apply the Bernoulli's theorem. Here the atmospheric pressure is P0. Here is also atmospheric pressure P0. So P0 plus, let the velocity, here is V, velocity of the fluid is V, V0, P0, and here velocity of the fluid is V0. So P0 plus half rho V0 square equals to, here P0 plus flow velocity being V, half rho V square plus what? The height and the depth is, let the depth is h, that is 247.5 meter, plus h rho into g. Now from equation of continuity we may write down that A0 V0 equals to A into V. So we may put V as V equals to A0 V0 by A. A0 V0 by A. So here we may write down P0 may be cancelled out from the both sides, half rho V square, half rho V square, half rho V square, it may be given in terms of V0. In terms of V0, the square of the speed with which water is coming out from the orifices, from the orifice of the lower end, we are to calculate that flow velocity. We are to calculate that flow velocity. So, we are to calculate V. So, V, we have to calculate, when we have to calculate V, then V0 equals to A by A0 into V. A by A0 into V, that is your V0. So you have to replace V0, half rho into A by A0 into V whole square equals to half rho V square plus H rho G. Taking half rho V square to the left hand side and making it common, half rho V square. This is A square by A0 square minus 1 equals to H rho G. So rho being cancelled out. V square equals to 2GH by A square by A0 square minus 1. This is. So this is 1 minus A square by A0 square. This should be 1 minus A square by A0 square. So 2 into G. G is 9.8. Take G as 10. G is 10. Into H is 247.5 into 10 to the power minus 2. 1 minus A square by A1 square. That is 0.01. So 20. This is 247.5, that is 49.5 by 0.99, that is your 50. So V square is actually 50, that is A. So the correct answer to the question number 24 is A. Now let us take the question number 25, that is the last question of part A. In the last question of part A, it is a surface tension related question. The radii of two columns in a U-tube are R1 and R2 respectively. So two columns of a U-tube having different radii, when a liquid of density rho is filled and angle of contact is 0 degree. The difference in level of liquid in the two arms, we know that height of the capillary H equals to twice T cos theta by R rho G. Now theta is 0 degree, cos 0 1, that is twice T by R rho G. So for the first case, H1 equals to twice T by R1 rho G. So for the second limb, H2 equals to twice T by R2 rho G. We are to calculate what? We are to calculate the surface tension. Now, the height difference is filled, the difference in level in two arms is H. So H is the difference in level of the two arms. So difference in level of the two arms is H, that is H1 minus H2, let it be, equals to twice T by rho G into 1 by R1 minus 1 by R2, let it be H. Next, then T equals to rho GH into R1 R2 by R1 difference R2. So our correct choice, rho GH R1 R2 by 2, there should be another 2, yes, twice T by, so T here is 2 into R1 difference R2, that is R2 minus R1. A is the correct answer. So our correct choice to the question number 25 is A. That is the end of our part 1 answer. And in the next part, we will discuss the rest of the questions, that is question from question number 26 to question number 45.